Is it the screen is visible to all?
Yes, sir.
Yes, sir.
Okay. In the last lecture, we've seen that one theorem that psi be an isomorphism of a field f onto f dash defined by psi of alpha is equal to alpha dash for all alpha belongs to f. Okay, corresponding to a polynomial f of x in capital F of x and f dash of t in capital F dash of t. Then we proved that the splitting field E and E dash of f of x, okay, belongs to capital F of x and f dash of t belongs to capital F dash of t are isomorphic to each other by an isomorphism phi. Okay, and the property phi of alpha is equal to alpha dash. Okay, now this next is corollary is there. Instead of here the f dash, we have taken replace this f dash by f. Okay, look at here. This psi is the mapping from f to f, phi is the mapping from e to e dash. Okay, and this f of x belongs to f of x, capital F of x, and this f dash of t belongs to capital F dash of t. And e dash and e are the splitting field of these two polynomials, and they are isomorphic to each other by an mapping phi. Okay. Now the next corollary is there, uniqueness of the splitting field. If suppose one polynomial is there f of x and e1 and e2 are the two splitting field of that polynomial. Okay. E1 and E2 are the two splitting field of the same polynomial f of x. Then these two splitting fields are isomorphic to each other. Okay. Now look at the statement first. Corollary. Okay, what is the statement? Uniqueness, heading. Uniqueness of the splitting field. Splitting field. Okay, now statement. Any two splitting field of the same polynomial. Any two splitting field of the same polynomial. The same polynomial over a given field. For a given field, capital F, are isomorphic. Isomorphic.
सर तुमचा आवाज खूप लो आहे.
Okay. Wait a minute. Wait a minute. Okay. Any two splitting field of the same polynomial over the given field f are isomorphic by an isomorphism. By an isomorphism leaves every element of f fixed. Okay, every element of capital F is fixed. Okay. What the statement says? Any two splitting field of the same polynomial over the field f. Okay, suppose this one is the f of x belongs to capital F of x. Okay, and the splitting field of this polynomial, if suppose E1 and E2 are the two splitting field of this f of x, then we have to show that this E1 is isomorphic to E2. Okay, there exists a isomorphism between E1 and E2, which leaves every element of the capital F is fixed. Okay, in the previous theorem, we seen that. Okay, suppose this one is the field F, and this one is the F dash, and in between F and F dash, there is an isomorphism psi. Okay, and this is the splitting field of f of x, E1, sorry, E, and this one is the E dash, and there is a isomorphism between E and E dash. Which one? Phi, which leaves every element of F is fixed. That is alpha, phi of alpha is equal to alpha dash. Such a property. Okay. Now, in this corollary, in a proof, in this corollary, we have to replace this F dash. The codomain of this phi mapping, F dash is equal to F. Okay. Now, this one is the what? This one is the capital F of X. Okay, and this polynomial belongs to capital F of X. And E is the splitting field of the F of X. Okay, now here replace F dash is equal to F. Okay, जर F dash is equal to F जर घेतला तर काय होईल, हा F of X belongs to capital F of X होता. ओके, तिथं जो F dash होता F dash of T होता, तिथे F dash of T च्या ऐवजी काय येईल, पुन्हा F of X च येईल. ओके, हा एलिमेंट ह्या ह्याच्यात आला डोमेन मधनं, आणि हा एलिमेंट कुठे झालाय, हा कोडोमेन मधनं आहे. ओके, इथून. ओके, प्रूफ म्हणजे कळेल तुम्हाला. इन द प्रूफ ऑफ द प्रीवियस थेरम we have to show that this E and E1 and E2 are the isomorphic to each other. Okay, where E1 and E2 are the splitting field of F of X. Okay, in the proof of the previous theorem, proof of the previous theorem, okay, take F dash is equal to F. Okay, and the mapping, instead of psi, we have taken here identity mapping, psi as a identity mapping. But we know that identity mapping is 1 onto an homomorphism, that is isomorphic mapping. Okay, taking psi as a identity mapping of capital F, that is we have psi of alpha is equal to I of alpha is equal to alpha. हा अल्फा कुठून येतो तुमचा, डोमेन मधून, आणि हा अल्फा कुठून येतो आता, टेकिंग इफ डॅश इज इक्वल टू एक कोडोमेन मधून येतो आउटपुट. ओके, so here psi as an identity mapping of F, that is psi of alpha is equal to I of alpha is equal to alpha for all alpha belongs to F. Okay, therefore psi is an isomorphism of F onto F dash, which is equal to what, F again. Okay, here we taken F dash of is equal to F. So psi is an identity mapping, that is isomorphism of F onto F. Okay, and it leaves every element of F is fixed. Capital F is fixed. Any doubt?
No, sir.
Okay, now suppose E1 and E2 with the two splitting field. E1 तिथे काय होतं मागच्या थेरम मध्ये, E and E dash, आता E dash ऐवजी इथे काय येईल, E2. Suppose E1 and E2 be the two splitting field of F of X belongs to capital F of X, ring of polynomial. Okay, now इथे काय होता प्रिव्हियस थेरम मध्ये, इथे तुमचा F of X होता. ओके, इथे काय होता, F dash of T, आणि हा E dash काय होता, याचा स्प्लिटिंग पॉलिनॉमियल. दिस E इज द स्प्लिटिंग पॉलिनॉमियल ऑफ F of X. इथे तुमचा डोमेन आणि कोडोमेन सेम झाला, इथं हा जो एलिमेंट असेल तिथंच F of X असेल इथे. ओके, इथे E dash ऐवजी काय असेल, E2 आणि E1 असेल. ओके, now here E1 and E2 with the two splitting field of F of X belongs to capital F of X. Then by above theorem, Then by above theorem, we have there exists an isomorphism. There exists an isomorphism phi in between E1 onto E2. Okay, E1 onto E2, such that phi of alpha is equal to psi of alpha is equal to alpha. Whenever this psi apply on the element of the field F, then it coincide with psi. Okay, by previous theorem, phi of alpha is equal to psi of alpha is equal to alpha for all alpha belongs to capital F. Okay, any doubt?
No,
No,
sir.
sir.
But what is E1 and E2? E1 and E2 are the splitting field of f of x. So this implies E1 and E2 are isomorphic by an isomorphism leaving every element of f, every element of capital F is fixed. Okay, any doubt? Hence,
No,
this is the
sir.
No,
proof
sir.
of the theorem. Any two splitting field of the same polynomial over the given field F are isomorphic. Okay, by an isomorphism leaves every element of capital F is fixed. Okay, now we will see some examples. Example number one. First one. Okay, let capital F be a field. Capital F be a field of rational number. Okay, capital F is a field of rational numbers. Determine the degree of the degree of the splitting field, the degree of the splitting field of the polynomial x cube minus 2 over the field f. Okay, what is f? F is the field of rational number is equal to set of rational number. We have to find the splitting field of this polynomial over the field of rational number. Okay, and whatever will be the field, that splitting field, you have to find degree of splitting field over q. ओके, काही का समजा हा ई हा त्याचा स्प्लिटिंग फील्ड असेल ई ओव्हर क्यू, मला काय करायचे डिग्री फाइंड आउट करायची. ओके, फर्स्ट आधी त्यासाठी स्प्लिटिंग फील्ड काढावं लागेल. स्प्लिटिंग फील्ड काढावं लागेल यासाठी काय करावं लागेल, मला याचे सगळे रूट्स घ्यावे लागतील. ओके, रूट्स फाइंड आउट करावे लागतील. रूट्स फाइंड आउट करून ते रूट्स कोणत्या फील्ड मध्ये एक्झिस्ट होतात तो फील्ड दाखवावा लागेल. ओके, नाउ आन्सर. Let first you have to find out the splitting field of this polynomial x cube minus 2. Okay, what is the splitting field? Definition of splitting field.
Binomial can be written as linear factors of that splitting field.
Product of linear factor. Okay, so f of x, suppose this is f of x is equal to x cube minus 2 belongs to capital F of x, where capital F is field of rational number. Okay, field of rational number. In the field of complex number, the three roots are, look at here, in the field of complex number. Field of complex number C. Okay, the three roots are, okay, what is the degree of this polynomial? X cube minus 2. Okay, so how many roots are there for this polynomial? At most 3.
Three.
Okay, at most काय 3च रूट्स असतील, at most पण नाही, equal to 3 roots असतील. Okay, in the field of complex number, the 3 roots are, which one? 2 raised to 1 by 3. This one is the one root. W into 2 raised to 1 by 3 W square, okay, into 2 raised to 1 by 3, where W is equal to minus 1 plus I root 3 divided by 2. Okay, so this is the W किंवा ह्याला आपण ओमेगा पण म्हणतो कधी कधी. ओके, कसं फाइंड आउट केलं हे? बाय डी एमआयरस थेरम. येईल करता कन्सिडर. ओके, ऍक्च्युअली हे स्टेटमेंट आपण शेवटी लिहायला हवं, पण मी आधीच सांगितलं. ओके, find the root of this polynomial f of x is equal to x cube minus 2. Consider x cube minus 2 is equal to 0. This implies BSc first year माहिती आहे ना, डी मोयरस theorem.
Yes.
X is equal to 2 raised to 1 by 3. Okay, so this implies, actually ह्या कसं येईल, wait a minute, x cube is equal to 2. Okay, so this implies x is equal to 1 येईल ना, 2 into 1 into 1 by raised to 1 by 3. Okay, which is equal to 2 raised to 1 by 3 into 1 raised to 1 by 3. Is it correct?
Yes, sir.
So this implies x is equal to 2 raised to 1 by 3. What is the value of 1? Cos 2 pi plus I sin 2 pi bracket raised to 1 by 3. Okay, 2k pi actually, हो ना? This implies x is equal to 2 raised to 1 by 3. Correct है ना? Cos 180, cos
Yes,
2,
sir.
cos 2,
Sir,
cos
याने
360 0, cos 60 म्हणजे cos 0, cos 0 1, I sin 0. Okay, 0 1 is 1 raised to 1 by 3. Correct. So this one is cos 2 pi k plus I sin 2 pi k raised to 1 by 3. Okay, so by T Moir's theorem, what we have? X, this implies x is equal to 2 raised to 1 by 3 into cos of 2 pi k or 2k pi divided by 3 plus I sin 2 pi k, okay, divided by 3, where k running from 0, 1, 2. Okay, put k is equal to 0. We get, this implies x is equal to, or x1, we can call this one x1 is equal to 2 raised to 1 by 3. Okay, how? Cos 0 1, sin 0 0, 2 raised to 1 by 3 into 1 is 2 raised to 1 by 3. Put k is equal to 1. So this implies x is equal to 2 raised to 1 by 3 into cos 2 pi divided by 3 plus I sin 2 pi divided by 3. Okay, 360 upon 3, 120. किती येते पहा व्हॅल्यू याची? किती येईल?
-1/2.
Minus 1/2. Okay, plus I root 3 by 2. Okay, which is equal to x is equal to, this one is 2 raised to 1 by 3. Okay, here we calculate x2, this one is x2. 2 raised to 1 by 3 into minus 1 plus I root 3 divided by 2. Okay, now put k is equal to 2. So this implies x3 is equal to, leave direct,
Yes, sir.
2 raised to 1 by 3 into ओमेगा स्क्वेअर दॅट इज -1. कॉम्प्लेक्स कॉन्जुगेट असतं फक्त, हा इथं मायनस करायचं. ओके, कॉम्प्लेक्स रूट्स कधीही एकटा येत नाही, तो कॉम्प्लेक्स कॉम्प्लेक्स कॉन्जुगेट मध्ये येतोय, तो प्लस मायनस. ओके, and this one is w, this one is w square. Okay, any doubt up to here? These are
No,
the
sir.
three roots of three roots of f of x. Now look at here. Which one roots? X1 is equal to 2 raised to 1 by 3. X2 is equal to 2 raised to 1 by 3 into w. X3 is equal to 2 raised to 1 by 3 into w square, where this w is equal to -1 plus I root 3 divided by 2. Okay, where now 2 raised to 1 by 3 is a real cube root of 2. Okay, is it correct? हा नंबर कसा आहे? इरॅशनल आहे, म्हणजे तो रिअल आहे. Okay, not a rational, it is a irrational. That means it is a real number, real cube root of 2. Okay, but 2 raised to 1 by 3, it is a irrational. So this is not belongs to our the field f is equal to q. Okay, that is the field of rational number. It is not a rational number. Okay, is it correct?
Yes, sir.
We have to find the splitting field of f of x. Okay, now, so this implies the polynomial f of x is irreducible over the field of rational number. Okay, all the roots are belongs to either irrational or complex, but not a rational root. ह्याला कोणताही एकही रॅशनल रूट मिळत नाहीये, त्यामुळे तो काय रिड्यूस होणारच नाही, त्याचे दोन फॅक्टर होणारच नाहीत कधी. ओके, the polynomial f of x is irreducible over f is equal to q. Okay, so we have the degree of f of x. What we have, degree of f of x is what?
3.
3. Okay, also 2 raised to 1 by 3 is root of x1. Okay, so root of f of x. Okay, so this implies 2 raised to 1 by 3 is algebraic. Okay, it satisfies the polynomial f of x of degree 3. Okay, so 2 raised to 1 by 3 is algebraic over the field of rational number, that is f of degree 3. Is it correct?
Yes, sir.
Thus, we have adjoined this element to the field of rational number. Okay, by field adjunction. Now, the degree of f of 2 raised to 1 by 3 over the field f, which is equal to what? 3. Okay, now we have to find the splitting field of f of x. असा एक field आपल्याला define करायचा आहे, find करायचा आहे, जो काय असायला हवा? We can write that f of x into product of linear factors. ओके, आता आपण हा एकच फील्ड असा डिफाइन केलाय की तो एकच ह्याच्यामध्ये रूट मिळतील, एकच रूट मिळतील. ओके, नाउ सपोज लेट capital E be a splitting field. Capital E be a splitting field of f of x. Okay, over the field f. Okay, now the field f of 2 raised to 1 by 3 cannot split f of x. Cannot, wait a minute, cannot splits this f of x. Okay, we cannot write that f of x into the product of linear factors in over the this field. Okay, so this cannot split f of x because a subfield a subfield of real field, a subfield of real field, it cannot contain the complex number omega into 2 raised to 1 by 3 and omega square into 2 raised to 1 by 3. Okay, suppose hmm, why this is not a splitting field of f of x? Because this field cannot split f of x. Okay, that means these are the two roots are not belongs to this field. Okay, so this implies f of 2 raised to 1 by 3 is a proper subfield of splitting field E. Okay, we have assumed E as a splitting field of f of x. ओके आणि हा फील्ड जो आहे तो स्प्लिट करत नाहीये एफ ऑफ एक्स ला, म्हणजेच काय होईल, हा एफ ऑफ एक्स काय होईल, प्रॉपर सबफिल्ड ऑफ ई. सो डिग्री ऑफ ई ओवर एफ must be greater than degree of f of 2 raised to 1 by 3, 2 in f of 2 raised to 1 by 3 over f. Is it correct?
Yes, sir.
हा तुमचा f, हा काय झाला, f of 2 raised to 1 by 3 आणि हा तुमचा ई काय, हा ई ह्यात सगळ्यात मोठा आहे, त्याचा स्प्लिटिंग फील्ड. ओके, so degree of E over F is must be greater than degree of F of 2 raised to 1 by 3 over F. So this implies degree of E over F must be greater than, what is the value of this one?
3.
3. Okay. Now we know one theorem. Which one? Look at this. Let f of x belongs to capital F of x, capital F of x be a polynomial of degree greater than or equal to 1, then there is a finite extension. There is a finite extension E, okay, of the field F of degree at most
N factor.
n factorial, very good, in which f of x has n roots. Okay, is it correct? If f of x
Yes,
belongs
sir.
to capital F of x of degree greater than or equal to 1, then there is a finite extension E of f of degree at most n factorial in which f of x has a n roots. By this theorem, we have there is a finite extension E of f, okay, in which the polynomial f of x, okay, has at most means less than or equal to how many, n factorial. What is the value of n here? Degree of that polynomial is 3 factorial, okay, which is equal to 6. Okay, so this implies degree of E over f must be less than or equal to 6. But we know that degree of E over F is equal to, by the transitivity of finite extension, degree of E over f of 2 raised to 1 by 3 into f of 2 raised to 1 by 3 over the field f. Okay, by the transitivity of finite extension, we can write the degree of E over f is equal to product of these two one. Okay, so this implies degree of f of 2 raised to 1 by 3 over the f. Okay, this degree is divisor of which one? Degree of E over f. Is it correct?
Yes, sir.
So this implies, and wait a minute, this one degree of f of 2 raised to 1 by 3 over f is the divisor of E over f. Okay, and we have the degree of E over f is less than or equal to 6. Okay, so this implies 3 is, what is the value of this one? 3. 3 is the divisor of degree of E over f, and we have the degree of E over f is less than or equal to what? 6. Then what is the possibility of this one?
6.
6.
6 or अशा कोणत्या नंबर आहेत जे लेस दॅन 6 आहेत पण 3 साठी 3 ने त्याला डिवाइड होतोय 3 and
3
6
and
ना.
6.
Okay, so hmm then possible values of degree of E over f is 3 and 6. Okay, but the degree of E over f is what? Greater than 3. Okay, greater than 3. Look at here. But find the theorem. Look at here. Degree of E over f is what? Greater than 3. So hence, here the 3 is not possible. Okay, so this implies degree of E over f is equal to what?
6.
6.
6. Okay, so this is the solution of the given problem. ओके, मग याचं स्प्लिटिंग फील्ड काय येईल? ई येईल. ओके, मग ई हा म्हणजे काय येईल? आता एखादा इथे तुमचा कॉम्प्लेक्स रूट आहे. हा कॉम्प्लेक्स रूट येण्यासाठी त्या फील्ड मध्ये काय असायला हवा? ओमेगा आणि ओमेगा, हा ओमेगा स्क्वेअर दॅट इज डब्ल्यू अँड डब्ल्यू स्क्वेअर काय आहेत? कॉम्प्लेक्स नंबर आहेत. म्हणजे या मी फील्डला, कोणत्या फील्डला? सेट ऑफ रिअल नंबरला. ओके, आधी माझ्याकडे जो फील्ड होता तो काय होता? सेट ऑफ इरेशनल नंबर, सॉरी सेट ऑफ रॅशनल नंबर होता. या रॅशनल नंबर मध्ये मी काय केलंय? कोणतं ऍड केलंय? या एफ ला मी काय ऍडजॉईंट केलंय? 2 रेज टू 1 बाय 3 हा इरेशनल नंबर मी ऍड केला. ओके, आणि ह्याचं एक्सटेन्शन काय येईल? याला मी काय करेन? ऍड आय हा ऍडजॉईंट करेन. ओके, म्हणजे माझा ई हा काय येईल? एफ ऑफ 2 रेज टू 1 बाय 3 हा आपण ऍड करावा लागेल, मला ऍडजॉईंट करावा लागेल, आणि ऑल्सो आय दॅट इज E is equal to, I have to join this f 2 raised to half f च्या ऐवजी काय q येईल? q of 2 raised to 1 by 3 and I हे दोन्ही एलिमेंट मला ऍडजॉईंट करावं लागेल. कोणाला? या q ला. So this is our the field E. Any doubt?
No, sir.
ओके, या फील्ड मध्ये काय होतील तुमचे? हा दिलेला जो एफ ऑफ एक्स आहे काय होईल? 2 रेज टू काय होता? एक्स क्यूब मायनस 2. In this field we can write this polynomial as a product of linear factors. Okay, and the degree of splitting field is 6 over the field F, that is Q. Any doubt up to here?
No, sir.
Okay. Degree of polynomial, degree of element, degree of splitting field हे सगळे डिफरंट कन्सेप्ट आहेत, त्यामुळे नीट लक्षात ठेवा. ओके, एक्झाम्पल नंबर सेकंड. Let capital F be a field. Capital F be a field of rational number. Okay, and given that this f of x is equal to x raised to 4 plus x square plus 1. This is the polynomial belongs to capital F of x. Show that f of w, where, sorry, capital F by G, capital F of w, where w is equal to -1 plus minus I root 3 divided by 2. Okay, is a splitting field. Is a splitting field of f of x, sorry, small f of x. Okay, small f of x, capital F of x, different आहे याच्यात बरं का. So show that this f of w is the splitting field of the polynomial f of x. Also determine the degree of splitting field. The degree of splitting field. Splitting field of f of x over the field of rational number, that is f q. Okay, any doubt in this statement? तुम्हाला एक polynomial दिलेला आहे, you have to find the splitting field of that polynomial. That means in that field you have we have all the roots of that polynomial in that field. Okay, then we can write that polynomial in the form of product of linear factors, and also we have to find the degree of that splitting field over the field of rational number. Okay, any doubt in this statement?
No, sir.
Okay, now look at the answer. We have f of x is equal to what? We have x raised to 4 plus x square plus 1, which is equal to, so this polynomial, by adjusting the term, we can write x raised to 4 plus 2x square minus 1 in one bracket minus x square. Okay, so which is equal to x square plus 1 bracket square minus x square. Okay, a plus b square, which is equal to, now use the formula a minus c, a plus b, a plus b into a minus b. Okay, which is equal to x square plus x plus 1 into x square minus x plus 1. Okay, so this is the x raised to 4 plus x square plus 1. Any doubt?
No.
No, sir.
Okay, now look at here. Suppose in some extension of f, in some extension of the field f, if suppose alpha is the root of x square plus x plus 1, then जर अल्फा ह्याचा रूट असेल, then minus alpha is a root of x square minus x plus 1 in that extension. Wait a minute, in that extension. Okay, काय कळतं का ह्याच्यावरून? If alpha is the root of x square plus x plus 1, then minus alpha is the root of x square minus x plus 1. How? Look at here. If suppose, hmm, if suppose alpha is root of x square plus x plus 1. ओके, जर हा अल्फा ह्याचा रूट असेल तर काय होईल? या पॉलिनॉमियलचा दिस इम्प्लाय हा सॅटिस्फाय करेल. एक्स स्क्वेअर अल्फा स्क्वेअर प्लस अल्फा प्लस 1 इज इक्वल टू 0. गिव्ह इट द इक्वेशन स्टार. Okay, so this equation we can write in this form: minus alpha square plus minus alpha, okay, plus 1, which is equal to 0. Okay, replace alpha by minus alpha. Put minus alpha in star. We get minus alpha square plus minus alpha plus 1. So this implies alpha square minus alpha plus 1 is equal to 0. Okay, hence we get minus alpha is root of x square minus x plus 1. Is it correct?
Yes, sir.
ओके, म्हणजेच जर अल्फा जर ह्याचा रूट असेल तर मायनस अल्फा ऑटोमॅटिक कोणाचा रूट होईल? ह्याचा रूट होईल. ओके, धस खालचं स्टेटमेंट नीट लक्ष द्या काय सांगतो. धस इफ एनी एक्सटेन्शन ऑफ एफ, एनी एक्सटेन्शन of the field capital F splits x square plus x plus 1, then it will also splits x square minus x plus 1. ओके, याचा अर्थ जर आपण या पॉलिनॉमियलचा जर रूट फाइंड आउट केलाय तर त्याचा निगेटिव्ह पार्ट कोणाचा असेल? याचा असेल. ओके, म्हणजे मी ह्याचा रूट काढेन आणि या तो काय करेन? एफ ला जॉईन करेन. पुन्हा मायनस अल्फा जॉईन करायची गरज नाहीये. एकदा अल्फा ह्याला जॉईन केल्यानंतर याच्यात अल्फा आहे, अल्फा स्क्वेअर, अल्फा क्यूब सगळे एलिमेंट आहेत. मायनस अल्फा ऍडिटिव्ह इन्व्हर्स सगळे आहेत त्याच्यात. Okay, so thus if any extension of f this splits x square plus x plus 1, then it will also split x square minus x plus 1. Okay, so this implies thus splitting field. We have to find the splitting field of x raised to 4 plus x square plus 1. Okay, so but here what? X square plus x raised to 4 plus x square plus 1 is reduced in two polynomial here. Okay, so thus the splitting field of x raised to 4 plus x square plus 1 belongs to capital F of x is the same as that of x square plus x plus 1, which is belongs to capital F of x. Is it correct?
Yes, sir.
ओके, ह्याचे रूट फाइंड आउट करतो म्हणजे कोणाचे रूट फाइंड आउट करतो? या पॉलिनॉमियलचे. इथे पहा, ह्याचे रूट फाइंड आउट करणं काय किंवा याचं फाइंड आउट करणं काय एकच गोष्ट होईल. ओके, पण याचा रूट फाइंड आउट करतो म्हणजे काय होईल? याचा मायनस निगेटिव्ह पार्ट हा याचा रूट होईल ऑटोमॅटिक. फॉर एक्झाम्पल इथेच पहा ना, समजा हा x square plus 5x plus 6. What are the roots?
-3, -2.
Minus 3, minus 2. काय येईल रूट्स?
3,
ओके,
2.
म्हणजे ह्याचा
2.
निगेटिव्ह पार्टच आहे हा. पुन्हा ह्याचा तुम्हाला काढायची काही गरजच नाहीये तुम्हाला. ओके, आता समजतंय?
Yes, sir.
ओके, नाव लुक एट हिअर. ह्याचा रूट काढतोय म्हणजे काय? ह्या दोघांचे रूट्स काढतोय. पण ह्याचा रूट्स म्हणजेच काय? ह्याचे रूट्स आहेत. सो हिअर the splitting field of fx raised to 4 plus x square plus 1 belongs to capital F of x is the same as that of x square plus x plus 1 belongs to capital F of x. Now let this polynomial as a g of x. Let that polynomial g of x is equal to x square plus x plus 1. Okay. Now, in the field of complex number, in the field of complex number, the roots of these two equations, roots are L करता minus b plus minus b square minus 4ac upon 2a. Okay. Then we find the roots are x is equal to minus b plus minus b square minus 4ac. Okay. Divided by 2a, that is 2. So this implies x is equal to minus 1 plus minus I into root 3 divided by 2. That is w is equal to minus 1 plus I root 3 divided by 2, and w square is equal to minus 1 minus root 3I divided by 2. Okay, any doubt?
No,
No,
sir.
sir.
Now look at here. This g of x, since g of x is irreducible, okay, over the field of rational number, okay, which is equal to, लिहून ठेवायचं, over the field of rational number. So this implies f cannot split, cannot be splitting field, splitting field of g of x. Okay, f cannot be splitting field of g of x. Suppose if this e is splitting field, e is the splitting field of g of x. Okay, then we have the degree of e over f must be greater than or equal to 2. Give it as an equation number 1. How? कसं आलं हे? By theorem. Okay, which theorem? F of x belongs to capital F of x of degree काय त्याची 2 degree आहे. So there is a finite extension e of f in which f of x has root n, and the degree of e over f is at most n factorial, that is 2 factorial, that is 2. Okay, because write down the degree of e over f जर असेल तर तो काय होईल? is equal to 1 असेल, is not possible. Okay, since e is not equal to f. Okay, f cannot split the splitting, okay, splitting field of g of x. Therefore the degree is either 2 or greater than 2. Is it correct?
Yes, sir.
Now, by the theorem, आता सांगितलेला theorem, the degree of e over f is at most what? 2 factorial. Why?
2.
Because the degree of g of x is 2. Okay, then there is an extension, finite extension e of f such that f of x has 2 roots, and the Degree is at most 2 factorial, which is equal to 2. So this implies degree of E over F is less than or equal to 2. Give it as an equation number 2. From 1 and 2, degree of E over F इथे greater than equal आहे, इथे less than equal आहे, म्हणजे काय होईल? Equal to 2. Okay. Hence, the field F of capital F of W contains a root W of G of X, and W belongs to F of W. This implies याचा स्क्वेअर पण काय येईल? एखादा ए जर एलिमेंट असेल तर त्याचा स्क्वेअर पण त्यातच असेल. ओके, पहा, जर डब्ल्यू तुमचा काय आला इथे -1 प्लस √3i डिवायडेड बाय 2, होय ना. त्याचा स्क्वेअर केला काय येईल पहा. ओके, -1/2 प्लस √3i, ह्याचा स्क्वेअर केला ए प्लस बी ब्रॅकेट स्क्वेअर केल्यानंतर काय येईल? हा येईल, मायनस येईल तिथे, हा एलिमेंट येईल हा. ओके, ए स्क्वेअर -2ab प्लस काय ए स्क्वेअर प्लस 2ab प्लस बी स्क्वेअर या फॉर्म्युल्याने केल्यानंतर. Okay, so this implies omega square or W square belongs to F of W. So therefore, F of W contains both roots. Which one? W and W square of G of X. Okay, thus F of W, okay, which is equal to what is F? Q of W. Q ला हा मी W adjoint केला, splits x square plus x plus 1, and hence x raised to 4 plus x square plus 1. ओके, हा स्प्लिट झाला म्हणजे काय होईल? हा पण स्प्लिट होईलच तो. ओके, सो दिस इम्प्लाइज द पॉलिनॉमियल g of x is irreducible over f, where the degree of g of x is equal to 2 and w is root of g of x. Okay, so this implies w is algebraic over the field f of degree 2. Okay, so this implies the degree of f of w over f is equal to 2. Hence, f of w over f of w is a splitting field of f of x is, and the degree is 2. Okay, any doubt?
No, sir.
ओके, मागचा एक्झाम्पल आणि हा एक्झाम्पल एक ऑब्झर्वेशन केलं की तुम्ही पाहायचं नाही का आम्ही काय सांगतोय. तुम्हाला इथे मागच्या एक्झाम्पल मध्ये पॉलिनॉमियलची डिग्री किती दिसते? क्यू. ओके, 3 डिग्री दिसते, पण एक स्प्लिटिंग फील्डची डिग्री किती आली ओव्हर द बेस फील्ड? ओके, या एफ ला आपण बेस फील्ड म्हणतोय. हा, डिग्री ऑफ ई ओव्हर एफ किती आला होता इथे? 6. पॉलिनॉमियलची डिग्री आहे कमी, पण स्प्लिटिंग फील्डची डिग्री ओव्हर एफ काय किती आहे? 6 असं असू शकतं. आणि इथे काय, डिग्री ऑफ पॉलिनॉमियल इज एक्स रेज टू 4 प्लस एक्स स्क्वेअर प्लस 1. Okay, degree of f of x here x raised to 4, but 4. Okay, and this degree of splitting field over the base field is equal to 2. Okay, confuse व्हायचं नाही इथे, कारण डिग्री ऑफ पॉलिनॉमियल हा वेगळा कन्सेप्ट आहे, डिग्री ऑफ एलिमेंट हा वेगळा कन्सेप्ट आहे, डिग्री ऑफ एक्सटेंशन फील्ड ओव्हर द बेस फील्ड हा वेगळा कन्सेप्ट आहे. ओके, एनी डाऊट अप टू हियर?
No, sir.
ओके, सारखं एक्झाम्पल सॉल्व करा. ओके, वेट अ मिनिट.